Welcome to the Oxygen Alliance YouTube channel, where we bring you videos on installation, maintenance, and various trainings on oxygen equipment and devices. If you have comments and or questions, drop them in the comment section below or write to us info@oxygenalliance.org. Remember to like our videos, subscribe to our channel, and hit the notification bell.
Hello everyone. Let me welcome you to our today's Oxygen talk. My name is Victor Mzembe. I am a Biomedical Engineer for Oxygen Alliance, and I'm your host today. I would like to know where you are joining us from, as well as your name. So you can write your name and your location in the chat. Also, if you want to get updates from Oxygen Alliance, you can also write your email addresses in the chat as well. So in today's talk, we'll be discussing about medical gas cylinder manifolds. And our presenters, Janet Douglas, who is a Biomedical Engineer for Oxygen Alliance, Dominic Mabanje, who is a Biomedical Engineer for OpenO2. We also have a special guest who is Pastor Soga, working with partners in health, and is a senior Biomedical Engineer. So during the presentation, we'll have ongoing polls. So we'd like to ask you to participate in the voting process. And also at the end of the presentation, we'll also have another poll whereby we'll ask you to give your feedback about the talk. So we also wish to ask you to participate in the polls. So without wasting much of your time, let me hand you over to our first presenter, who is Janet Douglas. Over to you, Janet.
Thank you very much, Victor. Welcome to this webinar. So in this talk, we're going to be discussing the medical gas cylinder manifolds. I'll take you through the first part of the presentation. And in this presentation, we'll firstly have an introduction or just a basic understanding of what medical gas cylinder manifolds are. We'll also look at the major components, the working principle, the infrastructure, installation and maintenance of these medical gas cylinder manifolds, the safety standards, as well as the manifold tests that are supposed to be conducted by engineers or technicians. So basically, medical gas cylinder manifolds are a group of gas cylinders which are connected in parallel, and they're designed to supply gas through a pipeline to an equipment or a building. This building mostly it's a healthy facility that is always there. You can talk of patient care areas such as operating rooms, intensive care units, and patient rooms. So the medical gases that are often used or that are piped mostly with the medical gas cylinder manifolds are oxygen, nitrous oxide, and medical air. Of course, currently, the nitrous oxide is not used as often as you can think of. But then this is one of the gas that is also piped using the manifolds. So I will take you through the major components of the medical gas cylinder manifolds. And firstly, we'll look at the cylinder banks. So in the picture, you can see in the presentation, we have a sample of a cylinder bank. So these are a group of cylinders that are connected to a manifold. They can either be two or more, but then basically you have a primary and a secondary bank. And the primary bank is the first line or first connection of cylinders that you would have when you connect your manifold, when you turn it on. And the moment this bank is empty, the system will definitely switch, or you have the right as the personnel to switch to a secondary bank. So the secondary bank in this case acts as a backup. Once the primary bank is empty, the secondary bank takes over. We also have pressure regulators that are there to reduce pressure to a usable level. So the pressures from the manifolds are very high and are not recommended to be used by patients in the outlet ports. So definitely we will need to have pressure regulators that will have to reduce the pressure to a level that is usable and recommended for the patients. And these pressure regulators also ensure consistent delivery of pressure within the pipeline system. We also have the pressure gauge that measures the pressure, and it's basically used in the monitoring of the pressures that are within the system. You can be able to see how much pressure you're getting from the point of manifold even to the end users, which is from the pipeline to the endpoints, which are the patient outlets. In the presentation here, you can see that there is a demonstration of how the pressure regulators looks like. And in the picture there are a number of regulators that you can have, because you need actually to have a regulator for the primary bank. You also need to have a regulator for the secondary bank, and even within the piping of your manifold. And you also have valves. And in this case, I'll be talking of the automatic valves that you have within your manifold. Firstly, you have a check valve. A check valve ensures that the gas flows in one direction. So if the gas is flowing from the manifold system going down to the pipeline, there shouldn't be any possibility of the backward flow of the gas in any way. So you need to have a check valve. You also have a shut-off valve. A shut-off valve acts like a valve that will enable you to separate one part or any part of the system. So in the case whereby you're using the primary side of your manifold, definitely there should be a shut-off valve that will shut off or will close the secondary side. And also, we also have a safety relief valve that is actually there to maintain the pressures within the pipeline or within the system. So in the cases whereby the pressures are very high, the safety relief valve will be activated to release some of the pressure so that it maintains the recommended pressure levels within the system. And it has been demonstrated on how this looks like in the picture in the presentation. Moving forward, we also have a control panel. So a control panel these control panels actually have an alarm system in it. And the control panel is installed to give an audio or a visual indication of a depleted gas supply within your system. It can also indicate the bank that is being active or that is being used at that particular moment, since I've already said that we have the primary and the secondary bank. And it also shows or indicates the pressure levels. If they are low or high pressures within the system, they need to be indicated. And the indicators, the LEDs are there, as you can see in the control panel. It's actually, it gives the LEDs, or it also gives you an alert through an audio. Like I've said, there's an alarm contained in the control panel. And you also have a pressure sensor, so that different outlooks or visibility of the pressure sensor, but this is just one of the pressure sensors that you can see out there. So the pressure sensor is there to sense the pressure, and it actually sends a signal to the alarm system or the control panel for it to indicate that we have either the low or a high pressure within the system or within the pipeline. Finally, we'll look at the connecting hoses, which are also known as pigtails. So these connecting hoses or pigtails, they just hook up gas cylinders, and mainly we have rigid or copper pigtails, and you also have flexible pigtails. So as it has been demonstrated in the presentation, it is recommended for us to use flexible pigtails when it comes to the cases whereby we'll be changing our cylinders now and then. If you'll be changing the cylinders frequently or replacing them frequently, it's recommended to use the flexible ones, because the moment you use the rigid pigtails, they easily clog and they cause leakages. So to avoid the cases of having leakages within your system, it's better for you to use the flexible pigtails. So at this point, a poll has been launched. So I would like to call the audience to please answer the poll questions. We just want to get feedback from you. So for those who are using laptops or computers, you have an activity icon or at the bottom left, at the bottom right of your laptop, and then you see where it's written activities. When you click there, it will direct you to the point where it's written pause. The moment you activate that one, when you click the pause, it will give you the 4 questions. So may you please answer those 4 questions. And for those of us who are using mobile phones or a mobile device, When you go to the bottom right of your phone, you'll see a menu button. There are 3 dots there. When you click it, it will take you to an activity icon or an activity button. And when you click that one, it will also get you to the polls. And the moment you click it, it will give you the 4 questions. So I would like to invite everyone to please answer these 4 questions because I'd like to get feedback from you, as I've already said. And reaching this far, I will pass it or hand it over to my fellow engineer, my colleague, Dominic, to take us through the second part of our presentation. Thank you very much.
Thank you, Janet. So I'm going to take you through how a medical gas manifold works, and also the pipings and the controls that are used when you have a medical gas manifold, and also when you have a piping system supplying gas from the manifold to the outlets. So it has already been said that a gas manifold is a system used to distribute gases from a single source to multiple locations. So we have several components here. Firstly is the gas source. So this gas source, this is where you are getting new gas. For example, if you have a cylinder filling manifold, you have a gas source which will be used to get the gas that will be used to fill in those cylinders. And when you have a supply manifold, it means that you have you actually have your cylinders as a gas source, which will then be allowed to go to the outlets through the pathways or the pipeline. And then you have the inlet connections. So these are the point of connections from your gas source into your manifold. And then you have the distribution pathways. So from your manifold, you have pathways to the outlets, and you also have pathways when you have a cylinder filling manifold from the gas source into the manifold, which will then be distributed to the cylinders that you are about to fill. And then you have outlet connections. So these are actually at the end of each pathway or at the end of the pipelines, where then you can connect your devices or your tools that are to be used at that outlet. So it can be the anesthesia machines or the ventilators. And then you have valves. So this will be at the manifold itself, at the pipe, and also at the pipelines. So the valves will be used to control the flow. So it's either to shut off the flow or to allow gas to flow through the pipeline. And then you also have regulators. For the regulators, that means they will control or they will keep the pressure that you want in the pipeline at a constant. So let's say you want 6 bars in your pipeline, you set your regulators to provide 6 bars in your pipeline. And then you also have the safety features. So these are actually for safety. For example, you have safety valves or relief valves. This will actually blow off the excess pressure in your pipeline. So this is actually to ensure safe operation. And then moving forward, we'll see different types of manifold. So there are different types of these gas manifolds. We have the supply manifold, then we have the backup manifold, and the cylinder filling manifold. For the supply manifold, this will be your main source of gas when you have no other gas plant at the site. So this means you source cylinders, or you procure cylinders filled with gas from elsewhere, and then you put on your manifold, and then you'll be supplying from that manifold. So you have no other gas source or gas plant. The manifold is the main source of gas that you have on your site. So as you can see in the picture, we have the supply manifold, and we have a block diagram showing the primary bank, secondary bank, and then the outlet. And then we have the cylinder filling manifold. So this is actually used to fill the cylinders. So you fill the cylinders at a higher pressure. So this means you need to have a gas source where you're getting your gas, and then you need to have the manifold itself through which you'll be filling the cylinders. A crucial component here is the booster pump. So for the gas source, mostly it will produce low pressures, not really low, but then at the lower end, for example, 6 bars, you have a gas plant producing 6 bars, but then you want to fill your cylinders to a higher pressure at almost 150 bars. How do you do that? You have to boost that pressure, that 6 bars, up to 150 bars that you want to fill in your cylinders. So how do you do this? You do this by using the booster pump. So the booster pump will be boosting the pressure to a higher pressure that you want to fill your cylinders. And then we have the backup supply manifold. So this will be used in case of when you have a main source, for example, you have a gas plant or an oxygen plant. And then when your oxygen plant is down, what do? You need to have a manifold which will be for emergencies. When the gas plant, the main gas plant is down, you'll be supplying using the backup supply manifold. So as you can see in the block diagram, we have a gas source, a backup manifold, and outlets. So how it works, the gas source is down, whether for maintenance or there's some fault or electrical fault, it has rendered your gas to be down. The backup manifold is actually going to take over from the main gas source, and then it will be supplying to the outlets. There are polls that have been now launched. You can also actually access them and then answer. This actually to make it interactive, and also want to hear your feedback. So you can now go to the polls and actually giving your feedback. Okay, I hope you have given your feedback, so we'll continue. So these manifolds can actually be classified into 3 classes depending on how they are operated. So we have said that the manifolds have two banks. Usually they have 2 banks, the primary bank and the secondary bank. So how do they operate? One bank will be supplying, and when that bank is empty, it will pass over to the other bank. So this changeover, this passing over, how this passing over happens, it's what will determine the classes. For the manual ones, it will mean that the operator has to be there monitoring the gas pressures in those cylinders. When the one bank is actually empty, the operator will then change from that bank to the other bank which is full. So let's say the primary bank was the one which was being used to supply. When it is actually empty, then the operator will change from that primary bank to the secondary bank. So the operator has to be there monitoring the pressures and be there to change from the bank which is empty to the next bank. So then he will be able to replace those empty cylinders from the empty bank. And then the other one, which is currently supplying non-empty, he will be able to change it again to the other one, which is actually full, and then replace the empty cylinders. For the semi-automatic one, this actually differs from the manual one because it will actually alert the operator that one bank is actually running empty. He has to come, or she has to come, to change it to the other bank. So the only difference with the manual is that it will alert the user or the operator to actually come to change to the other bank. So it will not be changing on itself, but it will alert the user to come and change it. Now for the automatic one, for the full automatic one, it will change on its own. So when the primary bank is empty, it will be able to change to the bank, to the secondary bank, which is now full. And then the operator can actually replace the empty cylinders. And when the other bank, which is now being used, is actually empty again, it will then automatically change to the bank which is full. So it does this automatically. So a crucial component here is the automatic changeover system. So this is actually the device which is used in automatic manifolds, where it has to change automatically. So it is actually a set of regulators. As you can see in the picture, there are regulators, and there are also pressure gauges which will be showing you the pressures in those banks which you have, the primary bank and the secondary bank. And also it has indicators which will be showing you the amount of gas that is in the banks, and it will also be showing you which bank is actually supplying at a time. So the automatic changeover system will be doing that on its own, will be changing from one bank to another on its own. The operator now will just be replacing the empty cylinders. So moving on to piping and control. So we have said we have a manifold, and then we also have piping from the manifold to the facility that we are supplying the gas to. So there are important things that you need to have when you have this system of manifold and the pipings. So you have manual valves, and you also have regulators throughout. So we have said that the regulators are there to actually control the pressure that you actually need in those pipelines. So you want 6 bars or you want 4 bars at the outlets, you use a regulator to control the pressure to be 4 bars in the pipings. And then you also have valves. So you need to have 4 valves when you have the system of manifold and the pipelines. So these 4 valves are actually required: the source valve, the zone valve, and the isolation valve, and the service valve. For the source valve, this will be located at the manifold. This will be used to isolate the manifold from the rest of the pipeline. So this will only be accessible by an authorized personnel. So we have said that it is located at or near the manifold. So we don't want anybody just to go there and actually close it and then stop the flow of gas to your pipeline. So it will only be accessed by an authorized personnel. Then we have zone valves. In the picture here is a zone valve box. So these zone valves are actually located at the zones. So at a facility, at a hospital, this can be in a ward. So these are located at near the outlets. So we have said like a ward in a hospital, where it can only be accessed. It can be accessed by the personnel in those zones. So if it's a ward at the hospital, it will be accessed by the medical personnel found in those zones. So these zones are used when there's an emergency, or there's a high pressure in those wards, or there's actually low pressure. So the medical personnel or the users in those zones can be able to actually shut off to stop the flow to those zones by accessing the valves, the zone valve. So we can see here in the box, we have the oxygen pipeline, we have the medical air pipeline, we also have vacuum. So the users in those zones will be able to access this. And it also has gauges, as you can see, which will be showing you the pressure, and it also has alarms which will be letting the users whether there's low pressure or there is actually higher pressure than actually required. Then we have the service valves. So these are actually put in place to allow for servicing or modification of lateral branch piping from the main line. So you have a lateral branch. Each lateral branch from the main line will have its service valve, and each zone will also need its service valve. So in zones, these service valves come in hand when we want to do maintenance on the zone valves. So you want to do maintenance on the zone valves, you switch off the service valve to those zones. You want to do maintenance on a particular section, you switch, you turn off the valve to that section without affecting the rest of the pipeline. And then you have the isolation valves. So these isolation valves are located at your gas plants. So they will be isolating each equipment at your gas plant. So it can be isolating the manifold from the booster pump, or it will be isolating your booster pump from the rest of the gas plant, or isolating an oxygen tank from the rest of the plant, or medical air tank from the rest of the plant. So these are isolation valves, isolating each equipment from the other at your gas plant. And then finally, we have outlets at the end of your pipeline, at the end of the pathway. So these outlets come in different standards. There's British standard, French standard, there's German standard, and there are other several standards. So a British standard outlet will only fit a British standard adapter. So you can take a British standard adapter and put it on a French standard outlet. It will not fit. So a British standard adapter will only fit into a British standard outlet. And also an oxygen adapter will only fit into an oxygen outlet. So a British standard oxygen adapter will fit into a British standard oxygen outlet. A British standard medical air adapter will not fit into a British standard oxygen outlet. So oxygen and oxygen adapter, oxygen outlet. British standard adapter, British standard outlet. So reaching this far, I will then hand it over to Pato Toga to continue with the presentation. Thank you.
Thank you so much, Dominic, and also Janet, for the nice presentations. I think just a reminder, we can still go to the polls that have been poured into the activities line, and then go through them and answer the questions that are there, just to give us feedback and also improve the presentation, and also make the whole discussion to be more active and interactive as well. So we're just continuing with a presentation about the manifold. I think just to iterate what Dominic has said when he was talking about the terminal outlet for oxygen, medical air, or maybe if you're using vacuum, you will see that the fact that the terminal outlets are specialized and are specific to the type of gas, it has also reduced the risk of using medical air, for example, or nitrous oxide on a patient that needs oxygen, because now the terminal is just specific that you can only plug in oxygen to that. Because you remember what used to happen was when manifold and also pipeline was not there, where we were taking in cylinders into the hospital wards, people could just see maybe the color of the cylinder, that it's black and white on top, maybe it's oxygen, but you find that there was no oxygen on it, and then you give to a patient that doesn't need that type of gas that is inside. So with the coming in of the manifold and the pipeline, it has reduced that kind of risk, that we, instead of giving oxygen, you're giving a different type of gas. But now the terminal outlet is very specific to the type of gas that you need to do, which is an advantage. And that makes this talk to be a very important talk, especially these days when we're talking about a lot of hospitals now are having these manifolds and also the pipelines. So that's why it's an important discussion to have, especially those working in a medical field. So, and also the risk of manually or physically handling the cylinders, moving them from place to place. Now the pipeline is there, the manifold is there, oxygen can just move in a pipeline towards the patient area, and now reducing also the space that used to be occupied by the cylinders themselves. Now they're no longer kept in the wards where the patient is. So oxygen is just moving from point to point. So thank you so much for the presentation. Just moving on, the cylinder manifold housing, that it can either be the backup manifold, or it can be the cylinder feeding manifold. It has to be properly housed. As much as we take care of the PSA plant properly housing it, also the manifold itself has to be properly housed with a nice shelter. So just to avoid contamination, whether it's rainwater or direct sunlight or even dust. So just to make sure that the manifold is well cleaned, and oxygen as an essential medicine, uh, making sure that it's delivered in its clean state, or it's medically uh, as it's supposed to be. So, and this prevents rainwater contamination and also direct exposure to sunlight. And the housing also must be well ventilated. So there must be at least the inflow and a good flow of air in and out, because if it's a manifold, it means there are going to be chances as well of oxygen leaking out, or maybe one valve is not closed and the oxygen is leaking. So if the housing is not properly ventilated, oxygen is going to remain in there and it's going to build up, causing the risk of fire. So anyone who comes inside the plant, we know what happens. The oxygen will end up clinging on the cloths, and if a person goes home with the very same type of PPE, for example, and is next to the fire, something can happen. An explosion of fire can happen. So to avoid that, we need to make sure that our housing for the manifold is properly ventilated and it's properly housed as well. Okay, so there are also questions and or polls that have been poured. We, just like as Janet had explained it earlier on, if you're using your phone or using a laptop, just go through the instructions he had given, and then we'll be able to access those questions. And we expect that we will be participative by answering those kind of questions. And our feedback will be highly appreciated. So the installation of medical gas pipe, medical gas cylinder manifold, we've seen that people normally use the copper, especially the copper that is medically graded for oxygen, because it's not every copper that can be used on the pipeline or on the manifold. There's a specific copper that needs to be used, including the thickness itself. It cannot be the one that you're using in the geyser pipes. It has to be the copper that is medically graded or oxygen cleaned, to ensure that the work that you're doing is purposely for improving the health care. So you do not want to bring any kind of contamination or any kind of pipe that is not compatible with oxygen work. So normally people you are using copper or any other type of material that is compatible with oxygen. So and the pipes can be classified according to the maximum operating pressures, like what are your desired pressures that you want to be operating your manifold, and also the pipeline itself. We've seen if the cylinder feeding manifold, you find that the pressure can go up to 150 bars. So you need to come up with a pipe that can accommodate that kind of pressures. Or if it's a backup manifold that is supplying into the pipeline, maybe it's a 150 bar, 142 bar, or 15 megapascals. So the pipes should be able to withstand those pressures and within the time, so that it's durable and it's serving the purpose. So, and then the pipes has to be able to withstand the fire and also the corrosion. And so they have to be corrosion resistant and also antimicrobial. They have to be high quality. Cleaning process should be done on it before the installation is done, or before the pipes are used on the manifold or pipeline. They must be well cleaned with the right materials, of course. And also the equipment that comes into contact with oxygen should be cleaned to remove contaminants that could lead to a fire, or any contaminants that could not just lead to fire, also that could also contaminate the patient himself or herself. Because remember, now they are going to move from the manifold because of high pressure into the system towards the terminals, the gas terminals, whether it's oxygen, whether it's medical air, whether it's vacuum, or any other type of gas that you're using on your manifold. Okay, so the design criteria now. So there are three basic criteria that determine the size of the pipes and components that are being used in the manifold. So it can either be the gas velocity, or it can be the pressure losses, or it can be the mechanical strength of the pipe itself. So the mechanical strength can be in terms of pressure, it can be in terms of temperature, or it can be in terms of the stress itself of the pipe, the mechanical stress. So all these factors should be considered when you're designing or when you're installing your manifold, or when you connect your manifold to the pipeline itself. So the pressure losses have to be taken care of. what is your input pressure? If it's 150 bars, maybe you're reducing it to 8 bars from the beginning, and then maybe the final one is 4 bars. So bearing in mind of all those pressure losses, that should determine the what type of pipe you're going to use, or what type of pipe sizing you're going to use. Whether you're going to use the diameter 22, outside diameter 2.18 millimeters of the copper pipe, or you're going to start with a big size of the copper, and then it reduces along the way until you have four bars, for example, on the terminal side of the oxygen, or on the patient side. So all those factors should be considered when the designing the designing and installation of the manifold and pipeline is taking place. So the materials that are used in oxygen pipeline system must be compatible, like we've said. They must be compatible with oxygen at the temperatures and the pressures used within the system. So must be cleaned for oxygen services prior to their use. I know there are a lot of different environmental factors that are different from country to country and from place to place. All those things should be considered, whether it's the humidity should be considered when you're choosing your materials, or your any kind of material that you want to be using for oxygen work. They must be compatible, they must be clean for oxygen, and also fire resistant, or taking care of all those factors when you're designing, and also when you're installing that pipeline. Otherwise, you're going to be in a situation where you put oxygen today, 10 cylinders, 50 liters, and tomorrow, before any patient uses it, the oxygen is gone, because the type of materials that they are used was not right. There are a lot of leakages, there are a lot of pressure losses, and you did not consider all that. And also, the violations of these requirements are extremely hazardous and can lead to fire. And we all know what fire can do. They can destroy everything, especially when you're talking about oxygen, 93% or 95%, or maybe if you're using oxygen from liquid oxygen tank, maybe 100% even of oxygen. So that can be extremely hazardous. So they need all these prerequisite or requirements must be taken care of before you install or you design your manifold or a pipeline system. And then here's what happens when you're if you're running a manifold that was welded. I've seen some manifolds they just connect with bolts and nuts. But if you're running a manifold that was welded or brazed with gas, then you have to think about using nitrogen inside. We know nitrogen is an innate gas on the periodic table. It's very stable and unreactive. So nitrogen must be pumped inside the pipes, so that when you're waiting outside, when you're applying heat outside, there's no reaction, there's no oxidation of the pipe inside internally. And there's a picture there on your left. You see the pipe where it was where the pipe was welded outside without nitrogen inside, without nitrogen gas, and then there was a reaction, there was oxidation happening, and you see those black deposits, and those things are dangerous because we're talking about you're going to be running high pressure oxygen on it, and the chances of those deposits can go towards the patient side, contaminating and even putting the life of a patient at a risk. And also on the right, you see the pipe that is well clean, that they had used nitrogen in their installation when they're welding the pipe or brazing, whether it's a pipeline or pipeline joint or even a joint on the manifold. And then you have whether it's a backup supply manifold or it's a cylinder filling manifold. Another thing that should be also considered is what type of valves are you going to use? Whether it's a bull nose valves or it's a pin index valves, and that obviously should be compatible with the type of cylinders that you have. If, for example, your manifold has valves that are bull nose, then you must have cylinders that are bull nose as well that can be filled on it. But if you have got cylinders that are pin index, but your manifold is bull nose, it means this is not going to be possible to fill those cylinders or to put those cylinders on the manifold for supply through the pipeline. So these things as well should be taken care of. The type of valves that you use on the manifold. It's always recommended to have at least both on the manifold, whether it's a backup or whether it's a cylinder feeding. That will give you an allowance to be able to be feeding your cylinders on it, both type of cylinders, or that will give you an allowance even to put the cylinders on the manifold for supply to the hospital. I see Vidumbi Konsoe has posted a question. Maybe someone will help us read that. And then the next slide is talking about the testing process, testing procedures after installation. So when the manifold is installed on a pipeline, or whether it's a manifold installed connected to the PSA plant for cylinder feeding purposes, the the leakage test must be performed. Remember, if this is not done, well, you're going to find yourself in a situation where the booster compressor is running. For example, if you're talking about a cylinder feeding manifold, the booster compressor is running, but the cylinders are not being filled because the whole of oxygen is just leaking out. It's just going to the atmosphere. So it's a very great danger. Like we had said, it's going to cause accumulation of oxygen in that room, and also there's nothing you're going to do. It's going to increase the feeding time. Instead of 2 hours feeding, maybe for example 5 cylinders, you end up taking the whole day to fill 2 cylinders because there's a lot of leakage on the cylinder feeding manifold. The same thing also on the backup supply manifold. If the leakage test is not conducted, you put 20 cylinders today. If it's the 10 by 2 or 2 by 10, you put 20 cylinders today. By tomorrow, all the oxygen has leaked out, has gone outside before a patient even used it, because the leakage test was not done, and all the joints are leaking out, or all the isolation and valve points are leaking out. So it's always crucial to do leakage test on the manifold and on the entire system or the pipeline to ensure that there's no leakage, to ensure that your manifold or the pipeline can withstand and hold the pressure within the time. So the pressure shall be gradually raised to the test pressure, whatever pressure you want to set, and all joints shall be checked with soap solution for leakage. And I know it's not every soap that is used. There's a specific soap that is oxygen compatible as well. So, for example, Simple Green or any soap that the manufacturer can recommend. And the testing pressure should be held for 30 minutes, during which joints shall be lightly tapped with a wooden hammer for over maybe about 1.5 kg. And if any leakage is detected, the line shall be depressurized and the defect shall be rectified before operation is handed over. And then the leakage test for the pipeline system shall be done at the maximum allowable working pressure for a period of about 12 hours, which is about half a day. And during this period, the pressure and the temperature readings shall be taken on an interval of 1 hour. So you're going to do pressure one, which is like an initial pressure before pressurizing it, and also the final pressure after pressurizing it within the space of 1 hour. And the same with temperature as well. And the gauge used should be tested for their accuracy and shall have minimum calibration of at least 0.1 kilogram force per centimeter squared and 0.5 degrees Celsius. And we know 0.1 kilogram force per centimeter squared is the same thing about 0.1 bars, because there's an equivalency of those units. So here goes your formula now, how you're going to calculate your leakage. So we said this should be done within for about 12 hours, but every 1 hour the readings should be taken pressure 1, pressure 2, and temperature 1 and temperature 2. And you're going to use those parameters to calculate the leakage that is on the pipe. So the test results shall be considered satisfactorily tested and acceptable if the leakage is less than 0.2% per hour. So, for example, if you pressurize your system to maybe 5 bars or 6 bars, and then you record those within an hour at an interval of 1 hour for 12 hours, and then you record every 1 hour, you calculate, and you see that your leakage is 0.2% of the total pressure that was raised, and then it means the system is can be accepted, and the results can be satisfactory, and you can hand over the system to be used, because it means the whole system, the manifold or the pipeline, is able to keep the oxygen when it's not in use, or it's able to keep the oxygen within that space of time. So it can be accepted. And after completing the test, the line shall be kept under pressure of at least 1 kilogram force per centimeter squared using nitrogen. Two pipeline commissioning is done. Remember, we are doing this testing process, this leakage test, not using oxygen, but using nitrogen, because nitrogen is unreactive, so it can be used for testing purposes before oxygen is pumped in or before other gases are pumped in. And then when handling when handing over or taking over of oxygen manifold and pipeline to the operation team, or whichever team is going to be in charge of the system, then proper protocols should be drawn containing the compliance of the following points. So the certificates for welding works should be given to the team that shows that this was done properly. So there has to be a certificate for that. And also the reports of inspection of internal cleaning of the pipelines. So remember we had to say the pipelines should be cleaned for oxygen purposes, and there should be reports that this work was done by the right people, and also reports of tests of accessories, tests of pipelines on strength and tightness, and also welding works, the logbook of it, and the list of welders who took part in the welding works. All these things is done just to ensure that the work was done following the standards, and also by the experts who know what they're doing on the field, because the whole system is going to be used on a patient, and you do not want to be the contributing factor towards deterioration of his health, but you want to be the factor that improves his life by giving the right services. So all these precautions or proper protocols must be followed, and the reports must be also handed over to the team. And then there's a pour again that has been that has been poured into the activity room. Please let's go in there and check the questions and then the response. We'll be waiting for your feedback. In continuation, we have got safety procedures as well that needs to be followed. Remember, oxygen is hazardous and highly flammable, so it means safety always must be the priority. So some of the important safety procedures to be followed are given as below. So all the specific requirements regarding safety protocols or safety procedures for oxygen, nitrogen, or acetylene or fuel gases shall be followed. And we've got a bunch number of guidelines that can be found and downloaded, whether it's from WHO or from manufacturers of a certain product that can be followed to ensure that the work that is being done or the system that is being used is certified and permitted for patient use in a health setting. The testing and cleaning and commissioning of oxygen gas pipe work, whether it's manifold, shall be carried out only in the presence of or with the permission and guidance of a trained and certified engineer. So all those things all those more safety procedures must be followed, including the right personal protective equipment when you're working with the oxygen equipment must be followed. All first aid and fire fighting facilities shall be readily available during cleaning, testing, and commissioning of oxygen pipelines. Because now you're now starting to use oxygen into the system, and you want to be highly cautious that in case of fire, there's someone who knows how to put down the fire, or there are fire extinguishers around that we can use to put down the fire, just to be on the safer side. And all arrangements for cleaning, testing, and commissioning shall have the occurrence of the safety engineer and the firefighting officer or its authorized representative shall be present during the cleaning process or testing or commissioning, just to ensure that all work is done with the help of different and various departments that take part in the oxygen work, including the fire department. Thank you so much reaching this far. If there are any questions, I think I'll hand over to Victor or Foster Center, who will now proceed with the rest of everything.
Thank you very much, our presenters, for the nice presentation. Now we'll take questions. But before that, I just have to remind you that there will be a feedback poll, and we'll ask you to participate in that poll to get your feedback on today's presentation. So it's time to take questions. And if you have any question, you can just raise your hand, or you can post your question in the chat and we'll read out to the team. So we have a question from Ditumiko Sohoya. The question reads, what are the appropriate or required diameter of copper tubings between cylinders and the whole system? I will read again the question. What are the appropriate or the required diameter of copper tubings between cylinders and the whole system? Another question from the same person to be Sohoya is altitude considered during installation? If yes, how is it adjusted? Considering the atmospheric pressure and generation of pressure banks and supply system. I will read the second question again. Is altitude considered during installation? If yes, how is it adjusted? Considering the atmospheric pressure and generation of pressure banks and supply system. Okay. Yes, Mphatso?
Okay, thank you so much. So what I wanted to say is maybe I do not have like a clear understanding of the first question on what is the appropriate diameter of the pipes between the cylinder and the system. I don't know which system we're talking about, because we were talking about the manifold either being the backup manifold or the cylinder feeding manifold. So if the cylinder feeding manifold and the system that we're talking about the TSA plant, or the backup manifold, the system we're talking about is a pipeline. So maybe it would be more nice if the question can be more specific, so that we understand what the one asking questions is looking for. But on the issue of altitude, I know it's one of the things factors that are taken into consideration, especially when you're doing the installation of the entire backup manifold in the pipeline system, because you will find that at some other points the pipeline goes above the ground. In other words, it runs inside in air, especially, for example, maybe in places where it's a driveway, cars will be passing over, and you do not want to run your pipe underground. Instead, especially for easy maintenance, maybe you want to run your pipe on top, where maybe the pressures can be high. So the altitude must be considered, because you have to think about the pores that are going to be used to hold that pipes in air steady. How strong are they? Will they be able to withstand the atmospheric pressure, or anything to do with that can disturb the physical the pipe itself up there? So it's one of the factors that are taken into consideration, especially when it comes to making sure that the pipe is steady up there. It's able to stand without falling down, especially when you're not running the pipe underground and just running it in the air.
Thank you very much, Mphatso, for your response. I hope that answers the question. So we have time for 2 more questions. So if you have a question, you can just raise up your hand, or you can place it in the chat, and I will read it out to the rest of the audience. Yes, Gilumbiko Soya.
Yeah, thanks, Victor. I had a question. I think I had to ask in the question section. So I don't know if it has been addressed, because I had network issues now that I've rejoined. I don't know if it has been addressed.
So you asked 2 questions. So the question was answered by Patotsoga. So I will just ask Patotsoga to come again, since you say you left the call. Patotsoga.
Thank you so much, Victor, and also Vinibigo, thank you for your question. So what I was saying is that when your altitude is one of the or component or factors that is highly considered when you're installing the manifold, especially in conjunction with the medical gas pipeline system, MGPS. So what I was saying is, you find that where you have your manifold, for example, which is where you're going to be feeding the manifold with oxygen, where there's a manifold, you find that you want to move your oxygen along the line, so through the pipes. And the pipes, you can either decide depending on the disturbance, or depending on what is also around the place. It might be there's a driveway, for example, where cars passes over in and out. So some will decide that we are going to run our pipes underground, which is underground, where cars will now be passing over. Or some will say, for maintenance purposes, it may not be easy for us to be maintaining or checking for leakages if we run the pipes underground. So we'll rather install the pipes above the ground, which is above the maximum height that we can have of a car. So in that way, now you'll have to think about the altitude, and also you'll have to think about the atmospheric pressure. So how are the pipes going to withstand? How are the pipes going to be hot? Are you going to put pores in between sections, maybe 1.8 meters or 2 meters apart? So those pores are the ones that are going to have the mechanical strength to hold those pipes. So how you're going to decide the strength of those pipes? You're going to decide depending on the atmospheric pressure, or depending on the environmental factors that you experience within that area. It can be wind, or it can be maybe even high rains that come with winds themselves. So that you make sure that your pipe is able to stand in the air or up there without falling down. So yes, the altitude is highly considered when you're installing the entire system, from the manifold to the pipeline, or if you're talking about the cylinder feeding manifold, altitude is it's still highly considered, because you're going to install the manifold somewhere, maybe up, and the cylinders will be below. So you still want to make sure that the manifold is highly secured in case of wind or any kind of atmospheric pressure that can affect the entire system. As for your second question about what's the required diameter, I wanted to understand, like, well, when you say between the cylinders and the system, like, which system are you really talking about? Are you talking about the PSI plant system, that is the manifold, the cylinder feeding manifold, or you're talking about the pipeline system, and that is the backup manifold? So I think it was just a matter of maybe clarifying what the specifics of your question, so that the people may be able to assist.
Okay, so it seems in the interest of time, that will be all for today's presentation. If you have any further questions, you can contact us at using our email at either you can use info@oxygenalliance.org or helpdesk@oxygenalliance.org. You have been a nice audience. Thank you for being with us today. And make sure you complete the feedback box. Thank you.